Corin and Leah are working on homework problems that involve arithmetic sequences. Ooh, arithmetic sequences. So that's an important thing. These are not geometric, arithmetic, so we get to new terms by adding a value repeatedly. Corin wrote down 2, 4, 3, 5 from one sequence, and Leah had 3, 2, and 0, 3 for a different sequence. Write an equation for each sequence. So I'll start with Corin. She had the points. I'll go 0, 1, 2. Her second term was 4, and her third term was 5. And then for Leah, I've got the 0, 1, 2, 3. I've got the third term is 2, and the 0th term is 3. So if I think about this, these are arithmetic, so they're going to be of the form t of n equals um, the slope, what we're adding each time, times n, and then plus b. The parameters I'm looking for here is my slope parameter, which is what I'm adding repeatedly, and my 0th term. And I can see that I've got the 0th term for this sequence, right? I know that my 0th term is 3. This one I don't have the 0th term. But I do see pretty easily here that this is increasing by just adding 1 each time. So in one, they're kind of similar. They're simple in different ways for each one. If I want to go back, the first term would certainly have to be 3 if I subtracted 1. And the 0th term would have to be 2 here if I subtract 1. So this one has a 0th term of 2, and I'm adding 1 each time. So this one would be t of n is equal to, my slope is 1, so I'm just going to write n plus b. So you can see if I want and I don't know why I wrote n, x and y up here, but I'm using n and I'm using t of n. If I want to know what for example, the third term is, I just take and I plug 3 in there, and 3 plus 2 gives me the 5. So this is a good mapping from the domain to the range. One of the things that happens in a sequence, remember, we restrict our domains. So here, n can only be those natural numbers starting with, well, actually starting with 1, right? So the first term in her sequence, this is where the sequence begins. The sequence would look like this: 3, 4, 5. The first term is 3, the second term is 4, and the third term is 5. So let's do the other one. So this one, I got the 0th term, but figuring out what I'm growing by is a little bit problematic. I can look at the change in my output values, and I'll just write that as change in y, and divide it by the change in my input values. I can see that if I talk about going from this point back to here, I can see that the change in my y's is 2 minus 3, and the change in my x is 3 minus the number 0. So 2 minus 3 is negative 1, and 3 minus 0 is 3. So this one has a slope of, I'm subtracting 1/3 each time. So if I take 3 and I subtract a third, this would be 2 and 2/3. If I subtract another third, it would be 2 and 1/3. And if I subtract one more third, I'd be at 2. So I can see that I'm decreasing, and I see my 0th term is 3. So this sequence would look like t of n is equal to negative 1/3 times n, and then plus the number 3. And again, this has the same domain restriction, right? So the first 3 terms in this sequence would be 2 and 2/3, and then I go to 2 and 1/3, and then I would just go to 2. So this one's decreasing by 1/3 each time, and starting at 2 2/3.